Hello, welcome to this pre-engineered building tutorial by TEKLA Structure. Today, we are going to use another useful tool of PEB tools to create connection between column and rafter beam. It is Feb Knee Joint, S93, component, used for creating a knee connection between a rafter and a column. The end plate connection can be located horizontally, vertically, or perpendicular to the rafter. Now let's turn the Select Objects in Components mode on. Press Ctrl+ F to open Application and Components dialog box. Input S93 into the search box and press OK. A Feb Knee Joint, S93, component icon will appear. Let's double-click on this icon to open it up. On the Feb Knee Joint dialog box, we focus on the Picture tab first. It helps to define joint dimensions and the connection type. There are three connection types. They are horizontal, perpendicular and vertical. This one helps to create web plate or diagonal stiffener. It has three options. The first is default option. The web plate is created. This one helps create diagonal stiffener. In this tutorial we are going to select this option. We are going to select this one. It helps to create corner lapse stiffener. Now input 293 into this box. It is horizontal dimension of the corner lapse stiffener. This one is knee stiffener edge distance from the secondary part web. We type 0 for this distance. Then input 100 for vertical dimension of the corner lapse stiffener. This one is dimension of the end plate extension from the main part web. We input 110 for this dimension. This one is the right extension. We input 102.04. This one is web stiffener edge distance from the main part flange. We put 178 for both stiffener plate. Then input 100 for the web stiffener dimension on the main part side. Now let's switch on the Parts tab. We use this tab to define the properties of plates and stiffeners. This one is stiffener creation. You can select whether bevel, square or no flange stiffener are created. Bevel is the default. This one helped to define how many web stiffeners are created, or whether they are created at all. 2 stiffeners is the default. This one helped to define whether bevel, square, or on inner stiffeners are created. Bevel is the default. These options define the thickness, width, and height of the part. Let's input 20 for end plate thickness. And type 185 for end plate width. Then type 0 for diagonal stiffener thickness and web plate also, because we don't need them. For web stiffener thickness, we input 8 mm. And input 90 for web stiffener width. This one is external stiffener, we input 8 for the thickness. This one is internal stiffener, we are going to input 8 for its thickness. Then input 100 for both width and height. This one is knee stiffener, we are going to put 8 for its thickness. And then input 90 for the width. This one is knee end plate, we are going to input 10 for its thickness. And then input 185 for the width. This one is corner lap stiffener, we are going to input 8 for its thickness. These options define a prefix and a starting number for the part position number. Let's input like this. For the diagonal stiffener and web plate, we leave it empty. These options help to define the material grade. Let's select Q345B type. These options define the name that is shown in drawings and reports. Let's input like this. Now let's switch on the Bolts tab. We use this Bolts tab to define the bolt properties, number of bolts, and spacing. You can select where outer and inner bolts are created. First, select 20 for the bolt diameter. Then choose 8.8 shocks for the bolt standard. Tolerance is the gap between the bolt and the hole. We put 2. Thread in mat defines whether the thread may be within the bolted parts when bolts are used with a shaft. In Create Outer Bolts drop-down list, we select Yes option. It will make all outer flange bolt group dimensions activate. This is bolt group dimensions along end plate width. The first is bolt edge distance. We input 47.5. This one is number of bolts. We input 2. This one is bolt spacing. We input 90. This one is also bolt edge distance. We input 47.5. These are bolt group dimensions along the end plate height. We are going to input 50 for the bolt edge. And input 6 for number of column. And then type 100 for the first spacing. Then input 80 for the second one. And input 460 for the third one. And then input 80 for the last one. After all, the bolt group dimensions should be like this. Now we are going to give these setup a name. Then save as in order to reload for the next use. Now hit OK to exit the Feb Knee Joint dialog box. Left-click on S93 Feb Knee Joint icon to run it again. You will see the TEKLA guide will pick the object in the lower left corner of the screen. Now pick the web plate of the column. Then pick the web plate of the rafter. This is a demo. and then hit the middle mouse button to create the connection. Now as you can see, we have just created a knee joint between column and rafter. If you let the end plate like this, the factory have to cut this one. Now we are going to cut it. On Edit tab, let's select the Fit Part End tool. When TEKLA asks, pick part to be fitted, just select the lower flange of the rafter. Then pick the first point on the cutting line. Then right-click on the screen, and select Perpendicular option from the pop-up menu, then pick the second point. Do the same procedure for the knee end plate. Now we are going to use the Polygon Cut tool to cut this web stiffener. On the Edit tab, select the Polygon Cut tool. Then pick the web stiffener. And then select the first, second, and the third point. Now pick middle mouse to close this polygon. Do the same procedure for the second web stiffener. Next, the lower one. Now we are going to modify this rafter length, according to the design. We are going to draw a construction line from lower end point of knee end plate, perpendicular to the upper flange of the rafter. Right-click on the screen and select Perpendicular option from pop-up menu. Now navigate to the View tab and left-click on Work Plan, then select Using 3 Points option from drop-down list. Then pick the magenta point for the origin, and then pick the yellow point for the X direction, and then pick any point on the right area of the construction line for the Y direction. Now select the construction line, then press Ctrl+C in order to copy this line to the right. Pick any point on the left of the construction line for the origin. Then right-click and select Perpendicular option from the pop-up menu. Move the mouse cursor nearby the construction line until the perpendicular symbol appear. Type 6000, then press Enter. Now click on the rafter beam, then hold down the Alt key and draft the mouse to select the magenta point. Right-click on the screen and select the Move option from the context menu. Pick the magenta point for the origin. To make it easy to select the intersection point, press Shift+2 to turn on the component's render wireframe mode. Thank you so much for watching and see you soon.